We're going to get an overview of this section, what you should know at the end. Be ready and let's go. At the end, you should know how to create your own data source model, use indexes, prepare your code for SQL injection attacks, and write your own transaction. This is the end of the class. Let's move to the next lecture. We're back to the SQL database with Java course, and we're going to make the idealization of the program that we're going to be developing in this section. Be ready and let's go. The idea of the app that we're going to be developing in this section is to make operations with our database and provide the results. To add artists, albums, and songs to our database, find the artists, find the artists' albums, find the artist for a given song that we're going to tell our application to give us, find the song metadata or additional information, find the name of an artist, album, and the track number for a song. Finally, but not the least, find the amount of records for each entity. This is the idea. This is the end of the class. Revise to understand if you don't. And let's move to the next lesson. We are in our section music database. Today we're going to see music SQLite database creation data source model. Basically, we're going to create a new database and we need to create a new project. This section is new. We're going to take that database that we've been working on using the command line sound, add that database to the same root of our project, and the project name in this case is going to be music. So create a project in your IntelliJ with the name of music or something else that you feel comfortable with. Copy that sound file that's inside of that zip, go back and download it if you lost that file, paste that file inside of the root where the source folder is. So be ready and let's go. Here I have this default project structure that IntelliJ creates for me. So if you have created a project, you should have the same interface that I have here. If you don't have this out folder, it doesn't matter. I have this out folder because I have clicked here on Run, but I didn't write any code here. So this is our basic structure. Let's copy that file and paste it inside of this music folder. I have here with me, I'm just going to click Ctrl C, come here, Ctrl V, okay, and I have sound.db. Let's take a look at the data that is inside of this database using our graphical user interface here. Let's just open the database. Okay, I'm just going to copy the path right here inside of music, paste here, go, find sound, click enter. Here we have, don't worry about this now, ID, name, artist, and here we have our albums. Do you remember? For example, this one, Looking for Myself, Hearts to Love, Trigger, 24K Magic, the 2020 Experience. We've been working on them using the command line artists. You can see here we have, these are the fields. You can see the songs that we have also are here. Please don't use the last version of this database where we have the list, the views, and so on. Just use the raw version, I can say that. Okay, we've seen right here that the data is here. Let's go back to our IntelliJ and start working on this. We're going to use the JDBC, obviously, and now we're going to make this code so different from the previous code that we had written. Now we're going to create a package that is going to contain the model of our data source. Let's come here, create a new package, give the name of model, and here let's create a class that's going to represent the data source. Inside of this data source class, we're going to make the connections, put the constant strings, and just make operations with the DB. Here we say data source. The name doesn't need to be the same, but if you want to follow this terminology, feel free to do so. Data source. Okay, before we start making anything right here, let's import our JDBC. Let's click here on File, Project Structure, Libraries, New. Okay, where are we going to find that file? It's on the downloads folder, in my case programs. Let me just Control C, come here, Control V, go to that path. Okay, click OK, OK, apply, OK. Let's confirm. Here we have our JDBC driver. Cool. Here in our data source, we're going to have the connection string, the strings that represent each column of our table names, and we're going to make methods to open and close the connections. Let's come here in our DB browser, open this database. Okay, and here we have, let's browse for data, come out here and see these albums. We have how many fields? 3. The ID, name, and artist. Okay, let's come here and write this into practice. Before we start writing the information related to the albums constants, we're going to create our constant for the database and the connection string. So PSFS, public static final string, is abbreviation. Hit enter, and this is a constant, uppercase letters, db underscore name. This is going to be equal, what's the name of this database? Is sound.db. Cool. Next, PSFS, and here we have the connection string, which is the string that contains all the details for the connection. Okay, JDBC, please make sure that you are writing correctly the connection string, because you may take, I don't know, maybe 30 minutes or even 1 hour trying to figure out what is the reason of having errors in your code. Connection string needs to be correct. Okay, SQLite, and let's copy this path where our database is living. Okay, I've copied. Here I have. Cool. Next, what we have to do, we have to concatenate, \\, concatenate with our DB name. DB name. Done. Let's go to the next line. In this line, we're going to start talking about the table. So we're going to create the constants related to the table albums. First, PSFS, this is going to be table albums. Okay, the name of that table is simply albums. PSFS, and now we have the column. Let's come here, album ID underscore ID, and that column is underscore ID. Cool. In artists and albums, we have the fields underscore ID. You may be wondering why I am not going to just give a generic name and use this ID to next statements that require the insertion of this ID. Well, I'm not going to be doing that, because if I want to change a table field where the name is underscore ID, I will have to change to all the tables, and that's not a good practice. So separate. Now PSFS column underscore album underscore name. What I'm going to have here in this, I'm going to have just name. PSFS, if you want to write, you can. Column underscore album, I'm just using PSFS because it's a shortcut. Artist equal to artist. Cool. I have here, let me confirm if that's correct. For albums underscore ID, name, artist. Okay, albums, it's correct underscore, name artist. Cool. Now let's talk about the artist. This PSFS table artists, and what we have here, we just have artists. PSFS. Okay, and then okay, here I have the column artists underscore ID, and what is going to be the value for this? Guess underscore ID. PSFS column underscore artists underscore name. What's going to be the value? Name. Okay, let me confirm if it's not missing nothing right here. Let me go to artists underscore ID name. Cool. And songs right now, ID, track, title, and album. Cool. PSFS. Okay, S, and I have the table that's holding the songs. The name is going to be songs. PSFS. I have the column inside of the song track. Here what I have, the track. PSFS. I have the column underscore song underscore the title of that song. Okay, this is going to be what? Title. PSFS. Okay, I didn't write the S. Column underscore song underscore album, which is equal to album. Okay, cool. Let me go back and see if nothing is missing right here. Okay, track, let me see, track, title, album, songs, track, title, album, and okay, let's put the ID right here. PSFS column underscore song underscore ID. This is going to be equal to underscore ID. Now that we have made these constants, it's time to make the connection happen. So we're going to open and close the connection. We're going to make methods for those operations. First, we need to have the object that is going to hold the connection. Let's put it here as first. The object is connection, obviously, and the name is going to be connection. Let's create a method here that's going to be used publicly. So public boolean is the return type, and the name is going to be open. This is just open the connection. So how we make the connection become opened? We simply say connection is equal to driver manager dot get connection, and we pass our connection string. Computer is slowing down. Okay, before we do that, we have to surround this code in a try catch block. I mean, Control X, put it here, then catch a SQL exception E. I'm going to say system out print line, oops, now with you, something went wrong, and we're going to concatenate the message in order to get details of what went wrong. Here we have, and we have to return false in case of the catch block becomes executed. And if our connection is successfully made, we have to return true. Cool, we have opened the connection right here, but we may try to close. So let's create a method for that is going to be responsible for closing our connection. Come here and just try. This is simply to execute the connection that close method of the connection class. So this is going to be void right here. What we are going to do is to see if our connection object is not equal to null. What is going to happen? We're going to close the connection. Okay, I have these red lines because I didn't use the catch block right here. Let me use the catch block to treat this exception. So SQL exception E and say something here. Oops. Okay, I'm going to use you. Oops. Unable to close connection. And now we're going to do what? Get the message. Here we have. Now we can test our database. Come here and write our code logic right here. Let's create an instance of data source and say this is going to be our data source. I can just make it simple, ds. This is going to be new data source, and here we're going to try to open this connection. Let's make something here. Just write ds dot open. Okay, let's right click, run, and see what we have as output in our console. It's building, so let's wait. Okay, we don't have nothing, so the connection was made successfully. That's why we don't have nothing here. Let's come here and click on open. What happened is that it just returned it true. Let's come here and make something a bit different. Say if the data source, which is this one, ds, is not open, what we're going to say, we're going to system out just couldn't open data source for you. And now we're going to simply return. Now let's close that connection, and here we have. Run it again. Okay, we don't have nothing. Beautiful. We are successfully making the things happen right here. We can also say if the s that open, that means it opened successfully. What we're going to say here, we can say open. Let's run it and see what happens right now. Open it. Cool. This is what I had for this lesson. Let's move to the next one. We're back to the SQL database with Java course. Today we're going to be querying the data with Java. Specifically, we're going to query data related to artists. Without further ado, all I want you is to be ready and get this started. Open the environment and let's go. When we query data, we know that we can return a result set, and then we can look through that result set. But let's make something here. We don't want to return that result set just because we don't want to have the classes using the methods that are going to be inside of the model package to understand the implementation in details of the model that we are using. Instead of that, we're going to be returning the list of artists. So we're going to implement array list, which is a list, and we're going to create separated classes for different type of manipulations: the artist, the albums, and the songs. For this video, we're going to talk about the artists. So the first thing that we're going to do now is to create our model for the artist inside of our package. So write artist and what we want to our artist. Well, here inside of the class artist, we simply have to model our artist. It has an ID and what? A name. So this is private to this class. So private int ID, int because it's an integer type, and in Java they're represented as int. Private, which is for this class. String is the type of the data, and this is going to have a name. This is simply a class. Now we're going to return getters and setters from our IntelliJ. We have to click Alt, Insert, wait, and come here, getter and setter, just to have methods to get data from this class and set data to fields of this class. Here we have our basic model. Now let's come to our data source. Here in our data source, I'm going to explain what is going to happen. In our data source, we're going to have a method that's going to return for us a list, and that list contains what? Details of our artists. without further ado, let's create a method for that. So this is going to be public. The return type is going to be list. Let's open these angles and write data type, which is artist. And the name of this method, will notice that we have to accept the importation here. So import class list. Okay, that's fine. That's right here the name of the method. This method is going to be responsible for querying the artists. So we can give any name that we want, but it needs to be a suggestive name. Let's write here query the artists, and here we can write our block of code, query with y. Okay, we know that to make the query, we need to have a statement and the result set. This statement and result set needs to be closed at the end with object reference.close method. Instead of writing those clauses, we're going to make a convention here. Use try with restores, because after the execution of that block inside of try or catch, the resources are going to be closed for us automatically. Let's create the statement and the result set. Try here. Let's open this parenthesis and close. Right, this is a statement type object. Okay, statement. This is going to be statement is equal to our connection dot create statement. Cool. Now let's come here. What's going on? At catch close, I'm going to add. Now let's add the result set, and this is going to be what? Result set equal to, we're going to get the set from our statement object. So statement that execute query. What's going on? Execute result set is equal to statement that execute query. Okay, don't worry, we're going to fix that. And the query that we want is to select all from our table. What is the table name? The table that we are working on currently is for the artists. Cool until this point. Okay, let's see. Cast the qualifier to java.sql statement. Okay, but what happened here? Maybe I didn't import the interface. So let me just see what importation was made here for the statement Java beans. Okay, I think it's the SQL one. Let me remove this for SQL. Okay, statement, and come here, see if I have this problem here. Okay, I still have, but let me catch it here. Catch, I'm going to catch the SQL exception E. This is going to be the name of the variable. Here I'm going to say that query failed. Okay, I'm going to say failed to query, and I'm going to print the information in order to get more details. We have created the statement object and the result set here. Here we have to create a list, and this list is going to hold what? The results of our query. The results are going to be in form of object artist. So for each result, we're going to create an object, and that object is going to be stored inside of a list, and that list is going to be returned. Let's create a list here, and the data type is going to be artist because it's the object here. Artists, because we have a list of artists, equals to new. Choose the data structure. I prefer to use array list. Array list, here we have. Now what we're going to do, we're going to say while the result set has next elements right here, what are we going to do? We're going to create a new artist. So we create a new artist, and it's going to be new artist. So we have an instance of this class, this object artist, and then we have to set the ID and the name. To set these IDs and the name, we have to get the ID and the name from each record that is being shown here in our code from the result set. So we say artist dot set ID to be equal to what we get from the result set as the int, and we want the int value which is in the column of the artist ID. So let's say column artist ID. Cool. Artist that set ID result set that get what we want to get the string, okay, which is in the column artist name. Okay, cool. I'm not setting the ID, instead I'm setting the name of my artist. Then what I have to do, I have to add this artist to the list. So artist is dot add what, I have to add this new artist right here. Cool. If you are confused what this means, I'm going to separate it into pieces. Here we have simple records being scanned with our while loop, so we're looping through all of them. Then we create an object of artist. This artist is initially with the values of ID and artist equal to nothing. And then what we have to do, if we have a record in a row, we have to get those data from that record and we save into some variables. Let's assume here that our variable of ID is equal to int ID, and we get data from the result set. So this line that is getting the data can be placed here to get the ID. Next, what we're going to have is the name. We just say result set. Let me just copy this line because it's result set that gets string column artist name. So this is the ID and the name that we are saving into variables, and this data is coming from our database. And here we create an object and we set the ID of that object to be the ID that we got from a record in our database, and we set the name to be here also. Then we add this artist that we have modeled, you can see, into a list of artists on this line 63. Basically is that. So while that happens, you keep adding, and what you do, finally you just return that list of artists, which is an array list. Cool. How I don't want to have these variables, you can have them if you want to let your code be readable, easy, and if you don't want, you can simply leave how it was, and that's the way that I prefer. So I'm going to copy this value, place right here in this parenthesis, open and close, cut, and place them right here and remove this. Cool. Catch. Well, if we catch something here, that means something went wrong, failed to query, and what we have to return is just a null. Here we have written our query the artist method. Well, now it's time to test. Come to the main method and make the operations happen. We know that we have to save this information being packed from our data source somewhere, and it's going to be in a list. So let's create a list of artists. Okay, the data type is artist and the name of this list can be artist. So this is going to be new array list. When we just use list and they say it's an array list, this is to allow us to make the class become more generic, so we can have the change to our data type with more flexibility if we want. And the first thing that we're going to do here is assign the result from our query artists to this artists variable. So we're going to say artists is equal to what? Our data source dot query artists. Cool. But we can simply just remove this redundant assignment by just copying this ts and assigning directly to the variable here while it's being created. So we're going to remove and have it right here. So this is going to be equal to what? this as dot query the artists, and it's done. Now we're going to check if our artist is not equal to null, is equal to null first. That means we don't have artists, so we're going to say we don't have artists, and we're going simply to return to act like a short circuit. We don't want to make something more. Now what are we going to do? If we have the possibility to reach the line 25, that means it didn't return and artists is not equal to null. Now it's time to get data from our artists method. We're going to use the for each loop. So we're going to say for what is the data type that we want to back is artist. Remember our class, and here is the artist name that we want to use to refer inside of our for loop. We're going to just say it's an artist, and it's inside of what our data list artists. Here we simply have to print information. First we're going to print the ID. Okay, but let's make something a bit beautiful. Say here artists details. Okay, just to make it more interesting in terms of visual appearance. So here we're going to say ID is equal to what? We have to get artist, which is this one, plus artist that get what? Get his ID. Next we're going to concatenate with what? We can simply say space. Okay, just put whatever you want here in order to separate. And now we want to print what? The name of that artist. The name of that artist is going to be what? Artist dot get name. It's done. Then we close our data source. Let's run it and see if we have our data being shown here in our console. I hope to have it. Let's wait, it's building. Okay, here we have our data is on our screen. We can't see artist details. ID is 1, name is Anthrax, artist details, name Ludacris, Chris Cornell, and so on. You see the beauty of working with Java and database. Here we have our details, simply like this info that we see. This is what I had to show you, and we are going to improve this code in later lectures. This is what you should know until this point because I told you, and let's move to the next lesson. End of the class. We are back to the SQL database with Java. Today we're going to talk about column index and order by for artists. Okay, we have the method to get artists, and then we're going to add the order by criteria, and we're going to change the column names for column indexes. Without further ado, let's open our environment and start coding. Well, we're going to be adding column indexes because it adds efficiency. It adds efficiency because it will go directly to the specified column instead of looking to all columns and find which matches to the string that we pass. For example, here we have the string column underscore artist underscore ID, and this is to simply refer to the ID column. Instead of using this string, we can use a column index. The index starts from 1. Be aware, don't start from 0, because if you put 0 you're going to get an exception. When we pass the name how it's here, the method needs to match the name with the result set that we get right here. Let's come here and work on our 3 different entities: the albums, the artists, and the songs. We're going to add indexes. The indexes are integer values. So let's come here, hit enter, and create the first index to our album, PSFI, hit enter. First is the index underscore album underscore ID, and this one is going to be equal to 1, the index for ID. Control D, duplicate, come here, change it for name, and change for artist. Change the values 2 and 3. do the same operation for the entity artists and the entity song. Come here, psfi index artist underscore id, and this is going to be equal to 1. Control D, just change the id to be name and change the value to b2. Okay, come out here, psfi, and this is going to be what? The index of songs. Let me come here, index underscore song underscore id, which is going to be equal to 1 d, control D, index. This one is for the track, this one is for the title, which is equal to 3, this one is equal to 4, and is going to be for the album. Okay, we don't have this last one since we don't have any more field to access. We have to change the names where we get the result from our result set to use the indexes that we have declared there. All we have to do is change this column artist ID to use the index, which is index artist ID, and this one is index album name. Let's run this and see if we have any bad news right here. I hope you don't have. Building parsing, let's wait. Cool, it's still working. Now imagine that we want to have the possibility to order by ascending order or descending order of the artist name our records. We need to have a parameter here in our query the artists method that is going to take information about that order. So if we have the value, we can manipulate our query in order to order by a specific criteria that he passes. We need to have conventions. For example, if the parameter that our user passes is equal to 0, that means there is no order. If it's 1, we can say it's ascending. If it's 2, we can say it's descending order. So we take a parameter here, which is an int type, give it a name. I'm going to say order of sort. This is the name of our parameter here, and we need to make the logic right here happen. With our conventions, we're going to start making a string. We're going to build a string. First, let's create constants for our class. The non-order is going to be equal to 0. The ascending order is going to be equal to 1. The descending order is going to be equal to 2. It depends on you. I'm going to come here and say psfi. The first one is going to be non-order, which is going to be equal to 0. Ascending order, which is going to be equal to 1. And this is going to be the descending order being equal to 2. Cool. Now let's come here and make the logic. We're going to build a string, so let's create a string builder here. I'm going to say query string equals to new string builder, and here we put select all from space, and let's append what to our query string. We're going to append what is our table artist's name here. Select all from artists. If the order of sort, the first should be lowercase order. If order of sort differs from what is our default ascending order, sorting order is non-order. If it differs from non-order, what are we going to do? We're going to append to our query string order by clause. After appending our order by clause query string, we have to append what? The column of our artist name. which is this one. And now we check if the order of sort is equal to ascending order. We're going to append to our query string ASC, which is ascending order. Else, what we're going to append to our query string, we're going to append the descending order, which is DESC. Cool. Let's ignore the cases. So the query string, we have to append what? Wait, my computer is slowing down. Okay, append collate, no case. We have a query string are updated but never queried. Cool. Let's just change here to be our query string and see if we still have that. No. We are writing the query. Select all from the tables here. If order differs from non-order, which is 0 in our case, we append order by. We append the column the column artist name here, because we want to get from the artist name. And we append the collect no case to ignore the sensitivity of the characters. And if order of sort is equal to ascending order, that means our user passed as the parameter the number 1. We want to append ascending order. Okay, let's give a space here. Else we want to just use a descending order, because if it's not ascending, it's descending order. Here what we have, query string, we're having problem. Okay, we have to convert it to a string. Cool. Now let's go to our method right here, which is inside of the main, and add a parameter. Naturally this is what, it's not ordered. Let's put ascending order, which is number 1. I'm correct or not? Ascending order is number 1. Cool. Let's run and see if we have. This should be sorted in the ascending order. Here we have, it's working. We can also specify directly data source that ASC order, because it's a static value. Okay, it will work. We can also make descending order sort here. You're going to see the first one is going to be 0. Okay, is descending order. And now we want a it was non-order, or no order. It's better to say no order. I'm going to rename this. Okay, how can I rename this? Is just come here, right click, refactor, rename, and it's going to be no order. Let's wait, my computer is not responding. No order. Hit enter. Cool, it has updated in all the places. Let's come here, run again, and our program is working how it should work. This is the end of the class. Please revise and let's move to the next. We're back. Today we're going to see DB browser and SQL. Without further ado, I want you to be ready and let's go. Our application has different components in terms of language. We have Java and we have SQL. Let's imagine that we are developing our application right there in IntelliJ, and what we do is use both of the languages. We have to be aware of the errors caused by the SQL and aware of errors caused by the Java itself. It would be interesting if we could minimize that possibility of errors by previously running our queries somewhere, testing if they are working perfectly, and just copy the queries and paste there, knowing that everything that is about SQL queries are working perfectly. We would minimize our time in the development of IntelliJ. We're going to be writing our queries, executing, seeing the output right here in the DB browser. That's new for us. Instead of writing those tedious queries using the command line, that is not a good, beautiful interface. And here you can easily edit your queries. I'm going to open the database right here I have on this path, and this is the database that we've been using. Well, this database is an updated one, a refined one. I've updated. So use this database from now until the end of this course. If it becomes necessary to make an update, I'm going to notice you. Open it. What changes I've made into this database? First, here on albums, we have a modification on the artist field. Now we require it to don't be a null value, because we can have an album not attached to a certain artist. That would cause our albums table to have the possibility to contain albums without an artist associated. And if you had browsed, you also would be aware of some null values that we had here. For example, on the album with the ID 8 and 9, we had null values here and so on. So I fixed those errors. Use this database. If you are using the previous one, I highly recommend you to update it to this one. Cool. Let's come here on the execute SQL, and here we can write our SQL statements. The first thing that we are going to do is to retrieve all the information from our database of artists. For example, select all from artists. A good news here is that you have the hints. Now click on run. Here we have, okay, select all from artists. We can say where what, where name is equal to, I can come here and say Sam Smith. Okay, let me run it, and here you have the ID and the name. Very beautiful. Our next lecture is going to be about developing a method that is going to allow users to query from albums name of a certain artist, giving their names. For example, I may say that I want to find albums that belong to Sam Smith, Ariana Grande, Drake, and other artists. Instead of developing that query right there on IntelliJ mixed with Java, the first thing that we're going to do is to develop our query here in our DB browser, test it. If it's working, then copy from here and paste right there. So let's make that right now. We're going to prepare the SQL statement, and on the next lecture we're going to be coding it on Java. So we select what we want. We just want the albums that name, and from albums inner join what, inner join with space, inner join artists. Okay, we want to make the join of the albums table with the artists table. Why we want to make them? Because they are related to each other with these two fields. Here we have the albums that takes this artist field, and this artist field value is a value of a certain artist in the column of ID. So we have to match these two values. Let's come out here in our SQL and continue. So we join these two tables. Okay, we're going to join artists on albums that artist is equal to what, artists that underscore ID, where what, artists that name, okay, that name is equal to, let's pick someone from now, Ariana Grande. Okay, and now we can order by albums that name collate no case ascending order. Okay, let's run and see if this query is working fine. Come here we have my everything and thank you next, and I know that these two albums belong to Ariana Grande. Here we have, okay, if we want to make this operation happen using our program that was written with Java, also we can simply copy this query and execute this query right there. We know that we're going to have a result being retrieved from our database because we've tested that this query is working. Okay, This is what I had to show you about using the DB browser and SQL. Feel free to write any other SQL statement that you want here, test it, see the output, and then use on your application. This is the end of class. Please revise in case of need, and let's move to the next lesson. Today we're going to create a method that is going to be responsible for querying albums by artist. So I want you to be ready and move. Here is where we left our program. So let's read it again, run it again and see if we have our outputs. Okay, remember that in our previous lecture where we used the VB browser and the SQL, we wrote a SQL statement that was responsible for doing what we want to implement our method today. Let's first make an idealization. This one returns just the artists. Cool. Now we want to get the album names when we know the artists. Let's come here and declare our method. It's going to be a public one. The return type is going to be a list of what strings, because they are just names that we want, and give a name. We're going to say query the album for artist. Cool. And what we need to have here, obviously we need to have the artist name and the order of sort, because we can specify an order in which the results are going to be retrieved for us. Int, we're going to say order of sort. Cool. Here is where our implementation happens. Let me copy this SQL that we ran in our previous lecture. I'm going to paste it here. Just hit enter right here so that we can see everything. And our idea is just to implement a string that is going to contain all this structure. For that, we're going to build it using a string builder object. String builder, I'm going to say this is a query string. Query string, you can give any name that you feel comfortable, equals to new what as builder. Query string. Okay, this is going to be a new string builder, and the first thing that we have by default is select. Okay, now let's talk about the appends that we have. The next thing that we're going to say is query string that append. What we want to append is the table albums. What table albums is just albums. Remember that we have declared this string in our code, so it's going to be select space albums. Know that we are copying it very well until now. Select space albums. Let's continue with the appends. Query string that append. What we have next is just a dot. Okay, it's a simple character. Query string that append, and we have column album name right here. Next, query string that append. What we have, space from space. Query string that append. What we have, the table albums. Next, we have to make what in a join. Query string that append space in a join space. Query string that append table artists. Okay, notice that I'm not writing everything. IntelliJ is helping me, so I just write some characters that exist in the name that I want to write. Query string that append space on space, hit enter. Query string that append. Now we want the table albums. Okay, unfortunately my computer suddenly restarted and now I have issues with the audio. I hope you get me well during this issue. Let's continue. Query string that append. We're here in table albums here, so let's append this period right now. Query string that append. We have the column album, artist, query string that append is equal table artist, the period right here, query string that append column artist ID, where table artist period right here. Let's give a space so that you can see very well. Query string that append column album name. We're simply copying the SQL statement that we have created here. Query string that append is equal backslash and code. We want to insert the code. That's why we're escaping a code with the backslash right here. Query string that append, we pass right now the artist name, query string that append, and we close the code, backslash code. We are done. Now if the order differs from no order, that means we have to append the order by and check if it's ascending or not in order to append ascending or descending. If the order of sort differs from no order, okay, we're going to say query string that append order by, query string that append table albums, column album name right now, query string append collate no case. And here we have to check if the order of sort is equal to ascending order. We simply append ASC, else query string that append DESC. And here we have. Now what we can do is simply print out the statement that is going to be executed here in our console. Let's print the query string, and now we have to create the statement and the result set and the list. The statement is going to be from our connection, the result set, to execute our query, and list to hold the results. Let's here open try and catch block, but try with resources. Here let's say catch a possible SQL exception E, and here we're going to say failed to query plus E that get message. Okay, and if that's the case, we simply want to return no. Let's open here and close the parentheses. Here we have our statement. We can say statement, and it's going to be connection dot create statement. We have to create our result set and say result set is equal to statement that execute query, and here we pass our query string to string. How we have created our statement in the result set, we have to create a list that's going to hold string type data, and here we say the name is going to be albums. This is equal to new array list. Okay, while our result set that next returns for us true, what we want to do is to get these results and add them to our albums. So albums that add result set that gets string, and what's the index? 1. We have to explicitly write 1 because this is the unique index available in our result set because we have prepared the statement that's going to be executed here to just retrieve results with one column. Finally, we have to return albums. We are done right here. Don't forget to put the semicolon here also. It's time to test and see if we have a problem with it. To test this, all we have to do is come here to our main code, create a list of strings that is going to contain our albums. This is going to be equal to what we have here, our data source, query the album for artist. Okay, here we're going to pick Ariana Grande. Okay, she's likey. Ascending order, it can be. Cool, we have a result. Now we're going to see if albums is equal to null. All we have to say is no albums, query failed. It's important. Return simply. That's going to cause a simple short circuit. Else, what we're going to do, we're going to say if albums that size is equal to 0, what we're going to print to our user is no album found. Cool. Else we have an album, that's why its size differs from 0. We're going to simply print, so for the value is string type, we're going to refer it as album name inside of our for loop inside of albums, and we're going to print what? The album name. Let's run it and see if we have a problem or not, and if we have, we need to fix its build. Here we have an error. SQL error, missing database, near no case, syntax error. Okay, what's happening here? Near no case, collate. Let's come here and see our collate in our data source. Where are you, collate? Where are you? Okay, we have. The unique problem here was about the space. Did you notice what I did? I just added a space right here, and now we have my everything and thank you next. So our application is working correctly. I know that I don't have an artist with this name right here in my database. Okay, do you see no album found? Cool. Let me go to Drake, see if I have something of Drake here on this database. Wow, I have live at jazz, something more live, nothing was the same. Scorpion views. Okay, who else? I think Rihanna. Okay, Rihanna. Cool. Here I have Auntie. It's working fine. Let me see Loca, for example. Do I have her results right here on my DB? Magnifica. Cool. Mr. Bao. I'm doing this test just to show you that it's working. Okay, no album found, but I think I have an album from the singer. I don't know, I think it's Mr. Bao. Okay, Mr. Romantic, Mr. Story of My Life. Okay, I do have. Now let me go to Maroon 5. Let's see if we have. We have. Let's change the order here. It's not ascending right now, but descending order. So we should first have V, then it should be red pill blues, finally hands all over. Okay, cool, it's working. Now I can say no order. No order, and yeah, it was just retrieved from our database, doesn't matter. Here we have. Okay, I'm going to leave it as ascending order. We do have it working. We can improve this code. If you want, you can put chained appends, like right here you just come and write append, then append, and so on. You can see something here on this code. A lot of static text is present. What we can do is here create an initial string until a part that we don't have an artist. Here, where is our artist name? Where are you? Let me find it. Until this part, this text is static. We could create a start string that would contain all this information and use that starting string inside of our string builder. The same, you can see that we have a static string right here until this point. Why don't we create two different strings and remove so much code that we have here? That's what we're going to do. And we're going to be optimizing the resource consumption, since we wouldn't have to build again and again these queries every time we call this method. So we can come here, create an initial string and the order by string. Use those strings right here in our method calls and just add the dynamic text. The difference that we can see with the new development that we are thinking about is that each time that we create this instance of data source, that initial static text would be present and we wouldn't have to recreate it more than one time. That differs from this actual implementation. So let's code that new implementation. I'm going to just comment this right here. Not for now, not for now, since I will have some red text right here. And I don't like red text, and I think you also don't like red text. Let me come here. Red text means errors. PSFS, query the album for the artist, and this is going to contain select space table albums plus appended period plus column album name plus from plus the table albums in a join table artists plus on plus table albums plus album artist equal table artists plus period plus column artist ID. Okay, where close table artists appended period column artist name plus, and here we just have to say equal escape character and put that code. This is our initial text. We won't append nothing from here, since the next text that comes in is that dynamic text that we receive from our parameter, and this is artist name. Now let's write PSFS. We can call it a sort string. So this is query the album for the artist sort string, and that is simply order by what, plus we have the table albums plus that plus column album name. We should collate no case, simply collate no case, and we are done, since the next things need to be dynamically appended when we make our comparisons. Let's go and use this new implementation. Let's come out. Where are you? The method. Here you are. What we are going to do is simply remove what we don't need and let the space be occupied by what is really interesting. So I'm going to comment this for now. Just give a simple comment. Cool. Okay, it's commented. Okay, let's come out here. In our string builder, we simply have to pass that string that we built. Query the album for the artist, not the source string. Next, what we have to append to our query string, the artist name. Okay. Finally, we append what? The code. Skip that character with a backslash, and here we have. Let's run this and see if we have a problem before we continue with our code. Here we have, it's working fine. This code now is not required. I'm going to leave it here so that you can compare how we have developed it. But technically we don't need it. That's why it's in form of command. I can even remove if you don't believe. I'm going to remove it, select it, remove, run it again, and you're going to see that everything is going to work fine. I'm going to leave it. Now we have to handle this part and query the album for the artist source string, and here we don't need the next texts since all of this was created inside of this string, and we need to leave this logic right here. Let's see if it's running. Is running. I can come here and change the order to be descending order. You're going to see it's still going to work. So you have to optimize the way that you write code. This is not the most appropriated construction until now, and you can see that our class right here is staying with a lot of static value strings. That's why some implementations recommend you to separate these static values and put them into a separate class. This is not what we're going to do in this class, but what we're going to do is to make that implementation just for this query the artist method. This is going to be simple, and we're going to do it right now. So let's come up here, right here, and make this implementation. How? That is the first method. We're going to implement it right here above. So PSFS is a string, okay, and this one I'm going to call what? Query underscore artist underscore start string. This is going to be equal to something. I want to refactor this in order to give a more suggestive name, so I'm going to rename it query the album for the artist start string. We simply have to write select all from plus table artists. This is simple. PSFS, and here we have the query artist sort string order by. Here we're simply writing the queries that we use it to write, but in form of static strings, plus table artists. That's what comes next. The period, the column artist name, plus what we have, collate no case, and space. Let's come and change the actual implementation to use what we have created. Let's come up here, string, select, okay. Here we can simply remove all. The query artist start string, select all from, you can hover and see what is going to have, select all from artists. That's cool. So table artists, we don't need it more, so we can eliminate. Then If differs, collect no case. Until this point, we can simply say query string that append. That's about sort query artist sort string. Okay, this one. Cool. Let's run and see if we have any problem right here in our artists. I guess we don't have. Yes, we don't have. We still have them being retrieved. You can even change to something like ascending order, and you're going to see that it's still working. Yes, here we have. Okay, I can leave it as ascending order, and here I'm going to make the same implementation. So it returned that, else check if the artist.size is equal to 0. Okay, and if that's true, just print no artist found. Okay, else we can copy this block and paste it here. So let's run again and see. Okay, why I'm testing the opposite possibility, like if the artist.size is 0, because I just want to have a feedback if I don't have any artist. This is the end of the class. Please revise in case of needing. Let's move to the next lesson. Today we're going to be creating the method responsible for querying the artist for a particular song. We can know the song title, and then we may want to know who is singing that song. Okay, for example, I can say 7 Rings. Who sings that music is Ariana Grande. So that's what we're going to build today, a method to solve this test for us. Given a song title, give us the artist who sings that song. So be ready and let's go. Let's open our DB browser. In our last lecture we left here. Let's run and see if everything is working fine. We have everything working fine. Okay, come here to our structure. Let's browse and go to our songs. I'm going to pick one of the Ariana songs, 7 Rings. We know that 7 Rings is the song that we want to know who is the singer. 7 Rings is inside of an album, and the album's ID is 43. Let's go to the albums. Okay, albums is 43. Let's find the ID 43 here. Okay, so the album with the ID 43 is Thank You Next, and the ID of that artist who sings the music inside of that album is 26. So we can go to the artists and look for 26. Okay, is Ariana Grande. That's exactly what we are going to do using our SQL. I'm going to open here a new SQL tab so that I can execute these steps, each one individually. Let's come here. First, select all from songs where what? The title is equal to 7 Rings. Okay, let me execute. I don't have. Okay, 7 Rings I have. Okay, 7 Rings album is 43. So let me come here and open a new tab. Select all from albums. I don't really need all, but let's just get all so that we can analyze everything. Select all from albums where underscore ID is equal to what we have here, 43. Okay, 43. Let's run. Thank You Next, and the artist of that album is 26. Let's open a new, and now let's select all from our table artists where the underscore ID field is equal to 26. Let's see. Okay, we know that who is the singer of that music is Ariana Grande. You can test to any other song. So let's build a SQL statement responsible for projecting to us not only the artist name, but we can generate also other components of entities involved during our searches. We're going to get the artist name, the album, and the song track, what we need for a song. SQL tab. Select what is our goal. Our goal is to get the artist name, album's name, and the song track. And from the table songs, we're going to make an inner join with albums. On where is it's going to happen, that inner join? On a place where the songs that album, which is the field that holds the album to which that song is associated, is equal to a certain ID inside of the album ID column. The songs that album is equal to albums that underscore ID. Let's come here to the next line and make inner join with the artists, and our inner join inside of the artist is going to be based on the place where the albums that artist is equal to the ID inside of the entity artist. Inner join. So let's come here and artists on albums that artist is equal to artist that underscore ID. Okay, and this is going to happen only where the song's title is equal to 7 rings. You know that 7 rings is a dynamic test, so you can change right here 7 rings to any other song title that you want. And now we're going to say order artists that name, then by the album. We won't care about the track. So albums that name, and we have to collate the case. Collate no case, and we want it to be in the ascending order. Let's run and see if we have any problem. We don't have any problem. We can just come up with this one with you. Let me check with you. Okay, uppercase. Cool, it's capitalized. With you. Let's see who sings this song. Is Drake inside of views, track number 8. Let me come here and make sure if it's correct. Inside of album 17, albums, where are you? Number 17 in the, no, not in the lonely, no, the ID is 17 views. Okay, and the artist is 10. See, here we have is Drake. Let me back to Ariana Grande, 7 rings. Here we have how we know that our query is working fine. We can go to our Java part and start coding. You can see that we only retrieve certain parts of artists, albums, and songs. It would be more interesting and organized to just create an object in Java that can only contain the artist's name, the album's name, and the track. So after we perform this query, how we have this output, we are going to be recording new objects based on the outputs that we get. Let's go to our IntelliJ and create that model. Let's come here, new Java class, artist based on the song. Okay, let's come here. What we have here, just 3 fields: the artist name, the album's name, and the track. Private string, the artist name. Next, what we have, it's also a private string, the album name, int, which is going to hold the track. Okay, now we have to write the getters and setters. Come here on getters and setters, select all, hit enter. If you don't want to use that shortcut, you can simply write. The output is going to be the same. Appreciate the code right here. Okay, let's go to our data source. Let's come in PSFS, which stands for public static final string, and now we're going to say query underscore the artist song start. This is going to be equal to what? I'm going to pass this query that we have here so that we can appreciate. We're simply going to copy what's here, select space plus the table artists plus that period plus the column artist name plus that comma with space plus the table albums plus comma plus column artist name plus that comma with space plus the table songs plus that comma plus the column song track, okay, plus space from the table songs plus we have to put here our inner join. Don't forget the space inner join. Let's come up here, inner join, okay, plus the table albums plus on plus, okay, I'm repeating plus every time, but that's what our code has, table songs, sorry if I'm not getting you annoyed, plus the column song album, okay, equal to what? The table albums, it's important to write properly, albums, okay. I'm going to pass this one to the next line. Cool. The table albums, we have that period, column album ID, album, okay, column album ID, cool, plus then second inner join plus table artists plus on table albums, that period right here, column album artist equal table artists plus we have to put that period, column artist ID, where now we have the songs, table songs plus we have that period plus column song title. Cool. Escape that character, open the code, and here we have, this is our query artist song start string. Next, PSFS, it's public static final string, cool. So query artist song sort string is going to be equal to what? Order by space plus we have this table artists plus that period, column artist name, okay. Next, what we have, this comma with that space, table albums, okay, albums, put that period right here, remove one space, column album name, okay, and collate, no case, cool. Okay, collate, no case, double L. We have our strings written. Now it's time to create a method. Let's come here and create a new method. we're going to retrieve a list containing what objects of the same type of our model. And now what's going to be the method name? Let's get inspired by what we had defined. Query the artist for song. We have to take the song name, obviously, and the order of sort. This is how we had defined it previously, just to maintain our structure. It doesn't necessarily need to be the same order of sort. Cool. Now let's create our string builder, which is our query string equal to new s builder, query the artist song, okay, start string, this one. After that we need to append what? We need to append the song name, and finally close the code. So query string that append, let's escape that character and close. Written. Now let's talk about the order part. It's going to be the same as we've been doing, and we're going to refactor more these so that we don't have repetitive code. If sort differs from what is our default sort, we can see here in other parts. No order. If it differs from no order, we have to append to our query string what that sort string, which is this one, query artist song sort string. Okay, then we need to check if order of sort is equal to sending order add to ASC. Else what we're going to append is the descending order query string. So try with resources, because we want them to be automatically closed. After we use statement, we get our statement from our connections. Create our result set. This result set is going to contain our data. And let's come here, say execute query, and this is going to be the query string. That's a string. Cool. I'm going to catch here a SQL exception E and just print the message saying failed to query plus E that get the message. Okay, and here we can start writing our logic. So we're going to have a list holding artists song, artists for songs. Okay, this is going to be equal to new array list. Okay, and here we say while what? Our result set next, which means as next elements we can start creating our objects, adding to our bucket, which is this list artists for song. After we do our records, we can simply return the artists for song object. So let's come here and say artist song. Come here, artist song is going to be equal to new artist song. Okay, now we're going to set the artist name, the album's name, and the track. Okay, so let's come here and say set artist song, which is our object, that set first the artist name. We're going to get the artist name from our result set. We get the string, and the string is firstly located at the column index number 1. Next, artist song that set, we have to set the album is result set that get string, result set that get int. After we have set the attributes to our model, we have to add that model to our bucket. Artists for songs that add this one artist song. Cool. And after we iterate to return our list. That's it. Here we have our method. Okay, And if we catch, what we have to do, just say no. Cool. Now it's time to pause this video and create a test one on the next part. We want to retrieve a list containing artist song object. So list, this one is going to be artist song, okay? And here we want our ds dot query the artist for song. Cool. What we want to query, 7 rings, okay? And what's going to be the order? The order is going to be, let me just choose the order, can be data source ascending order. Cool. Okay, this is going to be if artist song is equal to null. What you are going to return to me, you're going to say so, okay, you couldn't find an artist, so no artist for specified song, and query failed in case we have null, and we have null when we have the exceptions, okay? Else, what happened right here? MySQL installer is running in community mode, okay? Ignore that for now. Else, come here, and what we need to do is simply to check if artist song that size is equal to 0. Just print what? We can just say no artist for specified what? Specified song. Cool. Else, just print for what's the data type, artist song. I'm going to say artist song. Inside of artist songs, I want you to print out 3 lines. The first one is going to be the artist name, which is going to be equal to artist song dot get the artist name. Duplicate, okay? Now you get the album. I wrote Ctrl D, get track, that, then now album name and track number. Okay, let's see what we have. Let's run it. Failure to query. Okay, that's normal, so we need to solve. Let's come here, SQL error or missing database near 7 rings. Okay, I know what's happening. Let's come and give some space here. Where song title, okay, where song title equals, where is my data source? Right here. Where song title, it was here. The problem is right here. Where song title equal, that was a syntax error. Okay, here we have. So when you have an error, don't panic. It's your work as a developer to investigate what's going on and solve. Just pick different values, browse for the songs, come here to the main method, man with the bag, okay? And who is singing this song? Okay, we have Jessie J, This Christmas Day, track number 2. Let's change the order here. We can say descending order, okay, but you won't see any effect because we simply have only one here, okay? You won't have. I'm going to put something that I don't have. and I should get no artist for specified song. Cool, because the size is 0, but we didn't get null. That means our SQL statement was executed successfully and we didn't get any artist. But if our SQL code wasn't executed successfully, we would have an exception and we would have right here no artist for specified song, query failed. 24K magic, I know that is Bruno Mars. Let's come here. Yes, the result set metadata. When we were working in our command line using the SQLite3 program, we were able to see the schema of our database. Now when we are using JDBC, the support for this hits different. And that's why I'm going to show you this interface result set metadata that is going to allow us to get information about our schema. Without further ado, just open this interface result set metadata on your browser, the official Oracle documentation, and read with me. Is an object that can be used to get information about the types and properties of columns in a result set object. In other words, we can get information such as columns, names, types, attributes, and more. The following code fragment creates the result set object rs. The result set object is this one, rs, and is equal to stmt.execute query. Creates the result set metadata rsmd. Here we have the result set metadata. rsmd is equal to rs from our result set object that get metadata, and uses rsmd, which is the result set metadata object, to find out how many columns rs, which is our result set object, has, and whether the first column in rs can be used in a where clause or is searchable. In other words, what we do here is we make the query, then we call the result set get metadata to get the schema information on a table. Here we have our result set, we make the query, and we get the metadata from our result set. Let's open our environment and code so that we can see this in practice. But before we do so, I want you to check out this page where you have some important methods and variables that you can use according to your needs. For example, this method is responsible for getting the catalog name. The description says it gets a designated column table catalog name. Get column count returns the number of columns in the result set object. Get column name, it gets the designated column's name. Get schema name, get the designated columns table schema, and so on. So you can check out and use what really matters to you. We left our project here, so let's run to confirm that it's working well before we make any modification. Okay, here we have. So let's write our method here. This is going to be a public method, void one, and we're going to say query the song metadata. Write first here our string, which is the query string, query string, and we can simple query all from our table songs. So select all from plus the table songs. Next, we have to open a statement, and we open our statement using try with resources here. Statement is equal to from connection dot create statement. Next, we have to create our result set. Result set is equal to statement dot execute query, and we pass our query string. Okay, now what we have to do is to create the result set metadata. Result set metadata, call whatever you want, is equal to, we get the data, the metadata from our result set. So we say result set dot get metadata. Here we have, and we can declare a variable that is going to hold the number of columns. Int num of columns. This is going to be equal to result set metadata dot get column count. If you hover, you're going to see what it returns the number of columns in the result set object. Okay, let's make something right now. System out the number of columns for table songs plus number of columns. Okay, now let's sketch SQL exception E and simply print out here saying failed to query, and we're going to print the message right here. Okay, it's fine. Now say our data source dot query the song metadata, run it and see what we have. We know that we have 4 columns in our table song, so let's see if we have that output. Here we have. Now let's use a method that is going to return to us the column name, and that method is get column name. You can see in the documentation. So what we have to do here is iterate through our column fields and get the names. So here we write for int I equal to 1, since the index begins from 1, while I is less than number of columns I plus plus, and here we simply print out the column plus I in table songs has the name result set metadata, okay, that get column name on that position. Let's run and see what we have. Here we have the column 1 in table song has the name ID, column 2 in the table song has the name track, column 3 in the table songs has the name title. Okay, here should be less than or equal because we want to include the last column also. Here we have column 4 in table song has the name album. Explore this object and practice if you want to get information about your schema. This is the end of the class. Please revise in case of need, and let's move to the next level. The get count function and views. The get count function is a function that we're going to be written, and it's going to be responsible for retrieving the amount of rows that we have in a specific table. And views, we've been working with views, so we're going to transfer that view that we had developed in the command line to work on with our JDBC. All I want you to do now is be ready and move on with. Let's create that method. So public return type is going to be an int, and we're going to say get count, and here we pass as a parameter the table name. Create a string that is going to be our query string right here, and this query string is going to select count all, okay, from, and we concatenate with our table name, not the table song but the table that we have in the parameter. A statement object, we call it statement, is equal to connection.create statement. Next we have to create our result set object, result set, and this is going to be equal to statement dot execute query, and it's going to execute our query string. Now what we have to return, we have to return the result set dot get int, since it's an int value that we are going to get from this query here. Select all from the table name, and we look at the int value that is on the first column, since it's the unique one. Catch what a SQL exception E, and let's print out failed to get count. then we concatenate the message that we have. That's what we have to do. If our getCount method doesn't return a positive value that we expect to have, we have to return a value that is going to be considered by us as developers an error value. So let's just return -1. It will represent error for us. Come here to our main method and say ds.query the song metadata node. That song was getCount, and here we have to pass the table name data source, referring directly to the class data source dot and its table song. Okay, this is going to result in a value, and we have to save it into a variable. So we're going to say here int, and we can say count is equal to ds.getCount. Then print out you have plus count plus records in songs. So let's run it and see what we have, how many records we have in this table. Songs. Okay, we have here the output. You have 957 records in song, and this is correct. We know that. If we want to confirm, you can go to the DB browser and see that. Now let's move to the next part. The next part is where we're going to create that view that we had created using the command line. What we have to do, simply test that query if it's working on our DB browser and implement it here in our program Java. I'm going to copy and paste that query we created together and execute. I'm on the DB browser, I'm going to paste it, and here we create a view if not exists. I don't remember if we had written if not exists in the view that we had created together, but if we didn't write, just write if not exists. And now here we have referenced the albums that name as album, so that you get used to rename columns. Let's run it and see what we have. We have a view. Let's go to our database structure, go to browse data and see this view. You see that we have the name of the artist, the album, the track number, and the title. So what we are going to do here is to delete this view and make sure that we don't have nothing. Now that we know that this query is working, we can copy it and paste in our program. Where are you? Oh no, data source class, here you are. Okay, let's come up here, come up. I'm going to delete this code since we don't need it now. Come here. Here is where we have our static strings. Add our new string here. I'm going to put that code in form of comment so that we know what we are going to be writing as we usually do. PSFS, and I'm going to give this the name table artist song view, and I'm going to assign it a value of artist underscore list, because this is the name of our view as we see here. Now let's create that big static string, PSFS string, and this is going to be the view string. Create artist for song view. This is going to be the name, and here we start writing create view if not exists plus the table artist song view as select plus, now we have the table artists plus the period plus column artist's name plus we have that comma plus, now we have the table albums plus, we're going to hear many plus because we have many concatenations, column album name album name as plus the column song album plus the table songs plus what we have, that period, column song track, okay, table songs, column song title here. Next, what we have is from the table songs concatenate with the in join table albums on plus table songs, that period plus column song album plus is equal to plus table albums, okay, that period plus column album ID plus in join plus what we have next, table artists on table albums plus that period column album artist is equal to table artist plus the period column artist ID plus order by, let's put this order by right here, the inner join also right here, order by space, after the order by let's put the table artists, the period column artist name, okay, plus next ordered by the table albums plus column album name plus that comma space table songs, put the period column song track. Let's come up right here and start writing the method that's going to execute. Public return type, just a boolean to create the view for song artists. This is our method here. So we have the try with resources. We create our statement object from our connection. Okay, now let's come here and just execute that query. Create this one and you catch SQL exception E, and we're going to print failed to create what? It failed to create the view plus e.get message. Okay, if that happens successfully, we just need to return true. But if we have an exception, that means it didn't happen successfully, please return false. And let's go to our main method to test if it's working or not. If our data source that create view for artists is equal to true, we can just remove equals to true. If that's the case, what we want to print is say who you've just created the view. Let's run it and see what we have. I hope to have the output. Cool, you've just created the view. Nope, we don't have that output. Failure to create a view. SQL busy. The database file is locked. Database is locked. Why is locked? Let me come up here and see. Let me close this database. Discard. Okay, let's run again and see. Cool, we've just created the view. That's it. Now let's come up here to our DB browser, open the database sound and see if we have the view. Here we have the view. We can browse the data, come here and see the view. It's working fine. That means we have created successfully that view. What I can do now is come here, delete. Okay, I'm going to delete it, close, discard, open it. You can see the sound. Oh no, I should have saved it. Yes, let me open again. Sound, here we don't have any view, but if we come here and run it, we're going to see that we have the view. Come here, close this database, open again, sound, open. Here we have the view. It's working. This is the end of the class. Please revise if you need, and let's move to the next lesson. We are back to the SQL database with Java course. Today we're going to query the view that we have created and write a method that is going to remove the redundant code that we are going to produce today. Without further ado, be ready and move on with me. We are looking to our view artist_list, and this view relates the name, album, track, and title. With title I can get all that I want here, any other field. With albums I can get, with name also can get. We have a method in our program that is responsible for retrieving us the artist name, the album's name, and the track when we give it just a song title. For example, we have 24K Magic and we have the three columns here: the artist name, album name, and the track number. We can use our view also to get this information, and that's what we are going to do today. The query for that we've been writing in the command line. I don't know if you remember, but if you don't, here you have. Just select the name, album, track from artist_view under artist_list, I mean, where the title is equal to a certain title. Just for test purpose, we're going to write 7 rings. Let's run, and here we have Ariana Grande, Thank You Next. The track is 10. Let's come here to our Java program and implement. The first thing that we have to do is to make a string that is going to represent that query. Let's come here and write PSFS and give the name for this constant. We can say query view underscore. This is going to be song title info, since we're going to pass the song title and get the information. You can give any other name. We're going to implement that query that we have written in the DB browser. Select space plus what we have to write, the column artist name, okay, plus comma space plus the column song album plus column song track plus from table artists underscore view. What's going on? Let's put our table artist song view, yes, plus let's use the where clause plus the column song title plus is equal to something. We have to escape the character right here, give a space, and we are ready to build our method. Okay, let's come here down, let's write our method. Public return type is going to be list of our artist song object. and this is going to be query the song information view. What we're going to pass is just a string with the song title, simple like that. And here we are going to create our query string, and this is going to be equal to new string builder. Here we pass the initial query string that we have written, query song view song title info, and we append to our query string the song title. We append also to our query string the closing code. Now what we do is try with resources here statement. Our statement is equal to connection.create statement. Now we need to have our result set here. Result set is going to be equal to statement.execute query and our query string to string, simply. Now let's catch the SQL exception E and say failed to query the view plus e.get message. We have to create our list that's going to hold the results, and while our result set has information or result set.next, we create objects, add to that list, and finally return that list. Here we write our list of artist song objects and say artist song is equal to new array list, while our result said that next what we want to do is create an object artist song object artist, and say this one is equal to new artist song. Then we say artist, I prefer to call it artist song that set artist name to be equal to our result set that get the string on that column, artist song that set the album name, result set get the string on the second column. Next, artist song that set the track, result set get int on the third column. Okay, now we have to take this object and add it to our list. So artist songs that add right here, add method, the artist song. Okay, here we have. Then we want to return our artist songs array list, and if we catch something we want to return a null value. Let's go to our main method and write just some code to test if everything is going well. Let's come here and write a new array. Okay, let's say list first, but it's going to be array list of artist song. We can say artist songs 1, okay, because we have one already declared before. That's why we have this recommendation. Artist songs 1 is equal to new array list. We have to use our method that we have written before to just initialize this array. So we can remove this part here and say data source or ds dot query song info view and pass the string. The title is going to be 7 rings. Let's come now here and say if our artist song 1 is empty, what we're going to say, empty could not find results for the title, and we simply make a short circuit return. If the method achieves the line 79, that means it didn't return and it found something. So our artist song 1 is not empty. Therefore, we can get into a for loop and loop through all the results in order to find out what we have. Here we write artist song, say artist song inside of artist songs 1, and we simply print out coming from the view, and here I put the artist name plus the artist song dot get artist name. Next we print out the album name and the album name plus the artist song dot get album name. Next we print what the track number. Here on the track number we concatenate with the artist song dot get track. Here we have. Let's run this program and see if we have information about Ariana Grande. 7 Rings is the song title. It's building, checking sources, build. Okay, here we have our result coming from the view. A name, which is the artist name, Ariana Grande. Album name, Thank You Next. Track number 10. That's working fine. We can write here 24K magic and see if we have a result. Empty, and that's cool because the magic should have this M and not the lowercase 1. Here we have nope, 24K magic. Couldn't find results for that title. Let's see how okay the K also should be capitalized. Let's see if we have. Here we have Bruno Mars 24K magic. The track number is 1. I want to give you a challenge. The challenge is to write a method that is going to look for maybe the album name for a specific title, look for the artists, or just song titles that correspond for a certain pattern using the like. You don't need to use the equal, just to make sure that you are really understanding what we are doing and you know how to write queries using Java. This challenge is to get the information of the artist name, album's name, and the track number given a song title. But instead of using the equal, look for results that have a song title like the one that you are going to pass. For example, if I have here 24K magical and someone is singing a song with the title 24K magical, I should have the result of 24K magic that belongs to Bruno Mars and 24K magical that belongs to someone, and results that are like 24K magical, just like we have been doing using the command line. Use the like right now. It's time to check to our code right here. If you look attentively to this code here, what's happening here? String builder query string, replace string builder with string. Okay, it's better if it's needed because we don't have too much appends, but let's remove it and leave how it was. If you look to this code, you're going to see that this part right here is the same that we have in our code here. Query the artist for song. My advice is that you refactor this, putting these statements into a method. I'm going to give you an approach, and if you want to go beyond the approach that I'm going to give you, feel free to do. Here we can simply remove this code that is responsible for creating the statement and result, put into a method, just pass the query string since it's the unique thing that changes, and just return the result. Let's come here down and write the method that's going to do that for us. This method is going to be private since this is the only class that needs to have access to it. Is a list, and it returns artist song object, and we can say loop song artist results, and we just pass a string builder and say it's a query string inside of this block. Let's simply copy this code right here and paste here. We have our statement, connection statement, execute query, and this is going to be the query string that we pass. We leave our list right here. We iterate through our result set just to get information. We return the artist song sketch, and we're going to say failed to query only, generalize. Failed to query plus e.get message. And what we can do here with the return that we have from this method loop song artist result, we can simply use the same return to the color of the query the song info method. So let's come here and remove all of this code. Simply write return what's coming from loop artist result, and we pass our query string. We are done. Let's go to the query the artists for song and do the same. Right here we can simply say return loop song artist result and pass our query string. Here we have. Let's run and see if everything is working. Okay, here we have. We still run our program with no problems. If you find any duplicated code, you can simply create methods and remove that duplicated code. This is the end of the class. Revise in case of need, and let's move to the We are back to the SQL database with Java course. Today we're going to be dealing with SQL injection attacks and prepared statements to solve that. Be ready and move on with me. Let's run our program as we do usually before we make any change and everything is working fine. I'm going to make something different right here. I'm going to ask the user to insert information about the song title for me. I'm going to come here and say systemout.println, please insert the song title. And next we're going to use the scanner object to scan the user input, and this is going to be equal to new scanner since he's going to be inserting to our system.in, and create a variable that's going to be the song title. This is going to be equal to scanner.next line. Instead of passing this hard-coded 24K magic, I'm going to be passing the song title. Okay, let's run this program and see what we have as our output. Okay, we have everything here on the console, and now it's saying please insert the song title. I'm going to insert 24K magic. So Here we have it's working fine, and I'm going to insert our Ariana Grande song 7 Rings. Here we have artist name Ariana Grande, album's name, thank you next, and the track number is equal to 10. Okay, I'm going to run again, and I'm going to suppose that now I'm a user who knows how to work with some systems. Our user can come here and say 24k magic between quotes say or 24 is equal to 24. It can be just any number. I'm not going to put 24. I can say or 5 is equal to 5 or, and come here, hit enter. What do we have? We have every record, and none of these records correspond to the title that we have inserted 24k space between the block codes or 5 equals to 5. None of those titles is equal to what we have here, and what we have are all the records. Do you think this is something interesting to give to our user? Do you think this is safe? We just wrote this title and we have the access to every record that is inside of that view. This is SQL injection attack. Imagine if we had sensitive information like password, credit card, contacts, or emails, balances. We would be able to see what we shouldn't see. What happens is that when we build the query string, I'm going to come here in the data source. When we build this query string right here, we concatenate everything our user writes. He writes 5 is equal to 5, and 5 is equal to 5. Yes, 5 is equal to 5 for every record. All the records in our view will be returned. A user has injected a SQL statement into the statement that wasn't supposed to run. That's it. Usually who will make this type of operation is going to be someone experienced with systems, who knows how databases work, who knows how programs work, not a common user. Generally saying, it's going to be a hacker. Instead of building the query strings and new statement objects to execute the queries as we've been doing so far, query the song info like so, we should be using prepared statement objects. They can protect against SQL injection attacks, because when we use them, the user input is not concatenated to the SQL statement that will be running directly. Let's come here and appreciate our static string, query view title info for the view. I'm not liking this, so I'm going to delete, and I'm not going to take you out the concentration. What's really changing between query to query is the song title. That's what we are concatenating. The song title is the only item that changes in the queries. We have to create a prepared statement object, and we are going to create it right here after we create the connection. Private prepared statement, and I'm going to say we want this prepared statement for querying what for us? For querying view song title info. So I'm going to say query view song, okay, info view, it's view. Here we have our strings. We are going to create a new string that we are going to use in our prepared statement to prepare the statement that we want to execute. So let's come here, copy this code since it's going to be the same, give a new name, prepared statement, and here we are going to change the backward slash and this code, this question mark. What this question mark is? It is the placeholder character we use in prepared statements. Next thing that I want to tell you is that the placeholder character will be replaced by the title when we are ready to make the query. Let's come up here. After we create our connection, let's initialize our prepared statement object. Query view song title info view, and this is going to be equal to what? From our connection we want to prepare statement, and we are going to create it only once because it will improve the performance of our program if we just precompile one time. Here we have to pass the new string that we have created, this one, passed right here. Let's go to the method query the song info view and start making some modifications right here. Code block level comment. The first thing that we are going to do is open our try block and refer to our prepared statement object and say it to set the string, and it needs to substitute that first question mark, which is the placeholder, by what? By our song title. Next, let's create our result set object and say result set is going to be equal to query song view song title view dot execute query. It already has the query, so we just say execute query. Then we have to create a list that's going to contain our artist song objects and say this is going to be equal to artist song is equal to new array list. The code here is going to be the same as this other, so let's just copy and paste. And if we have an exception, we have to do the same thing. That's it. Now we can remove this code. We don't use quotation marks around the song title, as you can see right here in our placeholder. We don't use the quotation marks around the song title because when the placeholder is replaced in prepared statement, the database already knows that for each placeholder only a single value is going to be substituted. Let's come here into the close part. Here we also need to close that resource. So before we make close of our connection, we have to close our prepared statement object. So we're going to say if the query song title info view is not equal to null, what we are going to say, we're going to say close it. Now we are ready to go and try again. Let's run this program and see what we are going to have. Let's go to 24K Magic. Okay, now we can start writing 24K Magic between these block codes, or 5 is equal to 5, and or then close. Empty, couldn't find results for that title, and that's pretty beautiful because we don't have any record in our view with this title 24K Magic or 5 is equal to 5, or previously we were obtaining everything, and I'm going to show you that it's still working for correct titles. Here we have, coming from the view, we have Bruno Mars. I want to talk to you something that is going to be important when you work with prepared statements. Only one current result set can be associated with a statement. Using a statement to perform multiple queries, each time we query the existing result set will be closed and new gets created. So don't panic to close the result set right here. Let me show you query that view where it is. We didn't close the result set, so don't panic to do that. And one more important thing, when we use prepared statement, the values are substituted in the placeholder, but they are treated as literal values. What I mean by literal values, in other words, is that no part of the value that is substituted is treated as SQL. That differs from our previous implementations. So as a challenge to you, from now, start using prepared statements for your next statements where you feel you need to use prepared statements. This is the end of the class. Revise in case of need, and let's move to the next. We are back to the SQL database with Java course. Today we're going to talk about transactions. This is the part 1. Be ready and move on with me. Imagine if we want to use or in our query. Our query would be like this: select name album track from our view where the title is equal to 7 rings or artist is equal to Ariana Grande. 7 rings can change, Ariana Grande also can change. The most appropriate query would be select name album track from artist underscore list, which is the name of our view, where title is equal to placeholder or artist is equal to placeholder. Title here is equal to placeholder. For each value being substituted, we need to have a placeholder, this question mark right here. Notes about placeholder that you need to take with you from now forever. You can't substitute more than one value for one placeholder, and you can't inject SQL to them. That's a good advantage of having them when we are building our statements. You can only substitute values and can't use it, for example, to declare table names. Why? Because the prepared statement object needs to know in which table and fields it will work on to be able to pre-compile. Because if it doesn't know the tables and the fields, it will not compile, and you're going to have errors. You won't have even the possibility to run your program, since you will have a compile time error. Finally, use just to substitute values. Prepared statements help us a lot. They protect our database against SQL injection attacks, allowing our database not to be hacked through SQL injection attack. That doesn't mean our database cannot be hacked. You can use prepared statements with select, update, and delete statements. JDBC connection class auto-commits or saves any change we make in our database by default. Every single time we may call to the method execute to insert, update, or delete a record. The changes are saved to the database as soon as the SQL statement completes. Sometimes we may not want to commit those changes as soon as the SQL statement completes. But if we use JDBC by default, it will do that for us. Let's see this example. Our application is an e-commerce website used to buy products and sell. A user has a computer, which is a product, in the shopping cart, and the state is not bought because he didn't buy until now. To have the computer and change the state to bought, he transfers money to the app to buy the computer in his shopping cart. To make this, at least 2 SQL statements are executed. First, update the source account with the new balance. Second, update the state to bought. What if the statement 1 executed successfully, but the statement 2 failed for some reason? The user had $80,000 and the state is not bought. He transfers $2,400 to the app. In the statement 1, we update the source account balance to $5,600 since it's the result of 8,000 minus 2,400. In statement 2, we change the state to both. If statement 1 completes but statement 2 fails, $2,400 will go away and be missing. We can notice the failure and we would have to write code capable of handling any failures by refunding the money to the source account. But what if we can't do that because the S2 failed as a result of the database being down or any other reason? Think. Second example, we will add a new song to our database. What are the steps? First, add artist for the song to the artists table. Second, add albums where the song is on to the albums table. Last, add the song to the songs table. What if the statement 2 completes successfully, but S3 and S2 keep failing for some reason? We would compromise integrity of our database, since we would end up with records in the artists or albums table not associated with any song. If we have a code that treats multiple SQL statements, these different statements, as a single unit, it would be nice. Either a bunch of statements would complete successfully or none of them. That takes us to transactions. Transaction is a unit of work made against the database, or a sequence of statements treated as a single logical unit, propagation of one or more changes to the database. If any of the statements fail, the result of any previous statements in the transaction can be rolled back or not saved. For the first example, how S2 failed, the source account balance would have been rolled back to 80,000, and that's what happens in real-world scenarios. For the last example, if S1 and S2 happen successfully but S3 fails, then S1 and S2 are going to be rolled back. If S1 happens successfully, S2 and S3 keeps failing, it would roll back to S1. This is the end of the class, just the part 1, move on to the part 2. We're going to see transactions part 2. Be ready and move on. These are the properties of transactions. Transactions have 4 standard properties, usually referred as the acronym ACID. A stands for atomicity, all or nothing. Ensures that all operations within the work unit against a database are completed successfully. Otherwise, the transaction is aborted at the point of failure and all the previous operations are rolled back to their former state. If we want to update user balance and we want to update the state to be both in our application, if we successfully update the user balance but the state is not updated to both, what's going to happen? We are going to refund 2,400, so the value is going to be 8,000. Next, C stands for consistency. It ensures that the database properly changes states upon a successfully committed transaction. Isolation, changes are visible to other connections only after they are committed. Imagine if we had the change of 8,000 to 5,600 being visible to other connections while the state was still not both. It wouldn't be fair. And isolation ensures that the changes are going to be visible to all other connections only after they are committed. Isolation also enables transactions to operate independently of and transparent to each other. Next, durability. It ensures that the result or effect of a committed transaction persists in case of system failure. These are the transaction control commands. Commits is to save the changes. Roll back the changes. Save point creates points within the groups of transactions in which to roll back. Set transaction is going to place a name on the transaction. SQLite uses transactions by default and auto-commits by default. We have seen this. Until now we didn't talk about writing a code to save our changes. We were able to simply write the command to make the changes. It made the changes and saved the changes. When we work with insertion, update, and deletion, SQLite creates a transaction, runs the statement, and commits the changes. Simple like that. We've seen the possibility to turn off the auto-commit feature in the JDBC connection object. When we did that, SQLite stopped auto-committing changes, but they were still made as part of the transaction. SQLite commands used for transaction. These commands are begin transaction, it's used to manually start a transaction, end transaction to manually end a transaction. Commit will end the transaction. Commit save changes made by the transaction. If you use the commit, you're going to end the transaction, okay? And if you end, you're going to also commit the changes. So that's why people keep using end and commit interchangeably. Roll back the uncommitted change and ends the transaction. Commit changes before closing the connection is what you should do. If you don't commit your changes before you close the connection, what happens is that all the changes that you have been making will not be reflected in your database. In JDBC, you won't write transactions using the SQL and use the statement object to run them. Instead of that, you are going to be using inbuilt methods of the connection class to execute transaction-related tasks. These are the steps that you are going to follow. Turn off the default auto commit by calling connection.set auto commit to false. Second step, make your SQL operation that compose that transaction the bunch of statements, in other words. 3. If all goes as you expected, you will call connection.commit method to commit the changes. Else you're gonna call connection.rollback to roll back. Let's demonstrate. We will program our application to insert a song into the table songs, which has columns for song title, the ID of the song, the ID for the album the song is on, and the song's track number on the album. Before we add the song, we have to add the album it is on to the album's table, where we have the underscore ID of the album, the name for the album, and the ID for the artist. How do we get the artist underscore ID? We need to add the artist before we add the album. That's the logic. If the artist or album already exists, then we will not add them again. The user is going to provide the song title, the album, the artist, and the track number. This is the algorithm that we need to follow. Get title, album, track number, and artist. This is the first step. Second step, see if there's already a record for the artist. If that's true, jump to step 4. Otherwise, go to step 3. In the step 3, we're going to add the artist to the artist's table. The step 4, we're going to see if the album is in the album's table. And if that's true, we're going to jump to step 6. Otherwise, we're going to go to the step 5. In the step 5, we're going to add the album to the album's table. And finally, we're going to add the song to the songs table. We need to check for the existence of the song before we add. That's true, and that's what we have to do. But many songs can have the same title. We will have to check the song's album and artist involving query in all the tables. So for this application, we're going to assume that the song doesn't exist. Can I assume in a real world scenario? No, you can't. You have to make the query in all tables and update the view. This is for simplification purpose. You know how to make queries, so you can do it in your project. End of the class, and let's move to the next. We are back to the SQL database with Java, and we're going to be writing the code to test the insertion method in our program with our data. Be ready and move. I'm going to run the program to make sure that everything is working fine before we make any modification. As usual, we have coming from the view, everything is working fine. So let's come here to the main method. Before we close our connection, say data source. Before we close our data source, I mean that insert song, the song title, I'm going to put I love to code. The artist name is going to be Coder, and the album's name is going to be The Coder. The track is going to be number 1. Let's see what error we have. Unhandled exception java.sql.sql exception, add exception to method signature. We can fix it. Just clicking on it, it will add the throw SQL exception right here on the main method. But before we accept it, let's just leave how it was. Before we finally accept it, let's see how we can solve from here. Okay, do you see the color of SQL exception is gray? That differs from the other colors here, which are black. Let's hover and see. Exception is never thrown in the method, so we can remove. Let's come here, and everything should be fixed without having to throw that exception right here. We can run this program again and start writing 7 rings. Here we have. So this technically should be in our database. Let's use DB browser and see what we have. Open that database. Sound. We have 73 artists, decoder, beautiful. Artists 41, coder, beautiful. Songs 958, I love to code, beautiful. Everything is working how it should work. Let's run again and we are going to see a different approach. We should have the I love to code song being inside of our songs table, because in this program we didn't require that a song with a duplicated name shouldn't be registered in our table if it was for the same artist and the same album. In other words, we can have a song that belongs to the same artist and the same album in our database with a duplicated name. That's a challenge for you if you want to make that operation. You have all the tools until the stage of the course to make that happen. Let's just run and see what we have. Let's come here and update 959. So that's it. I love to code with a different ID, album 73, and let's come to see in the albums if we have the coder is only one artist, it should also be one coder. That's it. Let's just add message here so that we can keep track of what's going on behind the scenes. We're going to write committing the changes and setting to true. Here, before we roll back, also we can say roll back in action. Can come here and say connection dot roll back in action. Let's come here to our program, make a new record and say I love SQL and Java. Is going to be for coder? No. Let's create a new artist and say programmer is the artist name, and the album is going to be the programmer hub. This can be the same number of track. Run this and see what we have. Just put 7 rings. And another challenge for you, make sure that you update the view every time you make the insertion of a new record. You have all the tools for that. Okay, let's see if we have 41 is the amount of records. Let's just update. We have 42. Cool. Programmer. We have here in songs 960. Yes, that's working. I love SQL and Java. Here we have. Now let's go to artists. We have 42 albums. We have the programmer hub. I want to add a new artist here and say Shine. Album's name is going to be Rise Up. The song is going to be I Need One Computer. Let's run this program, but before we run it, let's come to our data source and simply make a provocation saying that we want to add into the parameter index that doesn't exist. We know that we only have 3 parameters. Let's say we want to add it to the parameter 35. Let's run again and see what we have as our output. Let's just put 7 rings. Okay, committing the changes and setting to true. Well, it's committing the change and setting to true with these exceptions. We have here to check what's going on. Let's come to our database, albums, Okay, we have 75 albums. Rise Up, it added. Let's go to artists. We have 43 artists. Shine, it added. Let's go to songs. We still have 960 songs. It didn't add. That's not how it should work. That's not what we expected to have. It should add all the 3 records in the 3 entities or nothing. We should simply come and see right here connection dot rollback in action and not see committing the changes. What happened? Take a look at what type of exception we have generated. We have array index out of bounds exception. We have told our code to roll back if we have catched a SQL exception type. Array index out of bounds, index 33 out of bounds for length 3, as we have here, is being thrown. And it's being thrown because we only have space for 3 placeholders and we wanted to add it on the index 34. This type of exception, array index out of bounds exception, is not exception of SQL. Instead of trying to find SQL exception, let's make a general approach calling everything exception, regardless of the exception. Every type of exception is a child of exception. In other words, they inherit the exception class or extend exception class. We can run this program again, but before we make that, let's remove these records that we don't want in our database. Let's remove Shine. Let's remove in albums this one, Rise Up. Let's close it, save, open again and see if everything's working how it should work. Okay, we have albums, artists, programmer. Now let's run this program again with this parameter index that we know doesn't exist and insert 7 rings. Okay, now it's working how it should work. Failure to insert song exception index 34 of bound for length 3, connection that roll back in action, committing changes and setting to true. That's it. We have to commit the changes if they are changes, okay, and we have to set it default to true if we don't make any changes or if we do make changes, because the next operations that are going to be made on our database needs to have the auto committed being executed in an automatically mode, because if it doesn't happen like that, any change that other methods make in our database will not be committed and will be a waste of time since they couldn't be recovered at a next time. So here we explicitly have to switch off and on or false and true because we are writing our own transaction, but we have to leave the default behavior finally. Let's come here and see what we have. We have programmer. Okay, no, we don't have programmer. Let's come here. We don't have the programmer. No, we have programmer, but we don't have these records and it's working fine. If the record was here, we would have the artist being equal to Shine, but we don't have, so it's working. Let's go to our songs and see. I love SQL in Java. Okay, we don't have what? I need one computer. It's working. Let's go to artists. We have 42 and we've seen we have albums, the programmer hub, but we don't have Rise Up. It's working. Let's come here and put it equal to 3, how it should be. Run this program again and see what is happening. 7 rings, committing the change and setting to true. Let's come here, update 75, it's working, rise up. Artists shine, we have album rise up. Okay, I'm seeing it for the second time. And songs, okay, I need one computer. You know how to work with transactions, prepared statements, make your database respond to your queries. That's what you should know, at least using the SQL database, and we have used SQLite at this lecture. This is the end of the class. Make sure that you revise it if you want, and let's move.